Hi everyone. In my previous video I told you about the example 1, but in this video I will discuss example 2. Let's take an example. A lot of 10 items contains 3 defective items, okay, from which a sample of 4 items is drawn without replacement. Means without replacement. One is drawn, then it is drawn, it doesn't come back. Let x be the random variable being the number of defective items in the sample. Means we draw four items from the 10 items, and in the 4 items x be the random variable of the number of defective items in the sample. Means number of defective items. What are the possibilities? Then 0 defective items, 1 defective items, 2 defective items, 3 is the last 3 defective items, because maximum number of defectives are 3. So we need to find the probability distribution function of x. For probability distribution, what we know from probability distribution is, means we need to find the probability of every possible event. Means we need to find, first we need to understand what the question says. Question says that there are 10 products in which 3 are defectives and we draw 4. But here is, first if we take about the possibilities of events, is that there can be 0 defectives in the 4 drawn. There can be 1 defective and 3 non-defective in the 4 drawn. There can be 2 defective and 2 non-defective. There can be 3 defective and 1 non-defective, and last one is 4 defective and 0. It can't be there because there is only 3 defectives, so we can't take that possibility. We have only 1, 2, 3 and 4 possibilities, which is 0 defective, 1 defective, 2 defective and 3 defective. Means we have to find the probability of all the possible event. Okay, there are 4 possible events when x is equal to 0, random variable x. Let's take like this. Here when x is equal to 0 means no defective in sample of 4. When x is equal to 1 means 1 defective in sample of 4, and like that x is equal to 2 defective, 3 defective in sample of 4. Okay, now here we need to understand the combination, permutation and combination. We know the number of ways to choose 4 items from 10 items can be written as 10C4. Okay, 10C4. First we need to find the probability at x is equal to 0. Means there will be no defective items in 4 drawn. Okay, for in the sample of 4. Here we how to find the probability. Simple, number of possible outcomes upon total number of sample space. So in this case, what will be the sample space? We are drawing the 4 items from 10 items, that will be our sample space, and we do not considering there are defective or non-defectives. We just have to draw, and the number of ways to draw is our sample space. So we have our sample space here, sample space. But our possible outcomes is this. How we get this? Here that 3C0 is number of ways to selecting 0 defective from 3 defectives. Okay, number of ways to selecting 0 defectives from 3 defectives, and the 7C4 is number of ways to selecting 4 non-defectives from 7 non-defectives. Got it? Means we need to multiply both of them, because both are occurring at the same time in the same event, because both are affecting each other. If there is 4 boxes are there, if we consider 4 boxes are there, if we put no 0 defectives, means no defectives are there, then there will be 4 non-defectives. If we put 1 defective here, there will be less than 3 non-defective, 1 less. Okay, if we put 2 here, 2 non-defectives, means here and here we get 2 defectives, means it comes from 3 to 2. Then if you put 3 defectives, then it comes to 2 to 1, means it is affecting by the increasing of defective. So both are affecting with each other. So both are dependent on each other. So we consider both of the events simultaneously, and we just multiply them, because both are, like how we say, we are choosing 0 defectives and 4 non-defectives, and we are using and. This multiplication is used because we use and here. Okay, so 3C0 multiplied by 7C4 upon 10C4. In general, we can write it like this, is that when Px is equal to small x is the event, then we write it 3Cx into, there is a multiplication here, 7C4 minus x, because when it increases it decreases, when this increases it decreases, okay, upon sample space which is 10C4. Here x can be 0, 1, 2, 3. Okay, now note is that nc0 is equal to ncn, because it is a combination, we know that is equals to 1, and nc1 is equal to ncn minus 1 is equals to n. This is a combination. I hope you know about this. And ncr is equals to n factorial upon n minus r factorial. This is to find the combination. And now come to our question is finding the probability at x is equal to 0. We get our answer is by solving like this, 1 by 6. And from the finding probability x is equal to 1, we get our answer of 1 by 2. X is equal to 2, we get 3 by 10. X is equal to 3, we get 1 by 30. I hope you will solve this. If not, please comment in below how to solve this. I will make a video on this. Okay, now the probability distribution is x px. Here we write the values of x, 0, 1, 2 and 3. Then writing the probabilities of all the events is 0. At 0 probability is 1 by 6, at 1 1 by 2, 2 3 by 10, and at 3 is 1 by 30. Okay, now the one thing we need to know about the theorem. Let fx be the function defined from R to R, means real to real, so that first fx, capital Fx नहीं है ये, small fx, it is small fx is equals to 0 for all x except, here is except, for a countable collection of points x1 x2 x3 dot 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 to xi dot dot dot. After that we have infinite values for which fx, small fx is greater than 0, that is small fx is greater than equal to. This is the property, we can say that, not theorem, it is the property of probability mass function, we can say that. Here if we add all the probabilities, here fx is nothing but a p of x, we write it p of x is equal to f of x. Okay, then f of x will be the probability mass, it's not a mean, probability mass function of some random variable x, capital X. Okay, in other video we will talk about other one more example. Okay, thank you.